All right, so we are up and running. Please confirm that you are still with me, please. Fine. All right, so we'll basically pull up our project and then we'll just continue from where we left off in our previous class. And before the end of this class, we should also be able to look at file storage with Cloudinary, hopefully, if time permits though, if time permits. Okay, so let's go ahead and let's open up our project. The project is in our desktop. We're into desktop. We're into KodeCamp beginner. Right, so we have our projects here. So we'll simply open up this project here. Simply open up this project here. Then we'll activate our virtual environment. All right, so I think this is where we left off in our previous class. This is where we left off in our previous class, and we made some crude activities. We interacted with our database. I think we did just one interaction where we simply create, where we simply create, and where we simply added information to our class, to our table rather. And then we said that in order to add information, we simply make an instance of that table, which in this case is user, and then we specify the values for each of the attributes for that class. And then we simply add that, and then we commit, refresh, and then we may choose to return a value, we may choose not to return a value, whatever we choose to return here is we are good to go. But this is the main process of adding information to your table, right? You create the instance of that particular class or table. So when I say table, I simply refer to our classes that we have here, right? Our classes that we have here. So we simply create the instance of that class, and then we specify the attributes alongside with the values for each of those attributes, and then we go ahead and we add or and commit, and then we refresh. So those are the process of adding. So we just continue from here. And basically I will add few more crude operations. So if you look at what we have in our previous code sample, if you look at our main.py, we see that basically we just create users into our database, right? We just create users. Once you submit your details, you do what? We simply create that user, right? And then we simply return that user, which at some point it shouldn't actually be like that, right? We shouldn't just create user because we want to create user, right? So what do I mean? We basically want to make sure that the user that we intend to create does not actually exist already in our database, right? So that's one of the checks that we want to actually do to avoid duplicate, right? To avoid duplicate. So we could also write another crude operation, right, that actually checks if a particular user, right, if a particular user actually already exists in our database. And if it does, then we do not want to actually create that user again. We simply want to let the user know, or that user with that specific name already exists. So as such, we cannot actually create it again. So how would we do this? How would we do this? Okay, so looking at our schemas, all right? Looking at our schema, where I want our email here, right, to be more like our primary key here, right? Probably because I'm sure that people's first name and last name may likely be the same, but I'm also sure that an individual email can never be the same, right? My email address can never be the same email address with all of us here, all right? So as such, in this case, then what I want to do is I want to check if a user with a specific email already exists in our database, right? Already exists in our database. So we could do that. We could carry out that crude first, and then before we finally get to before we finally get to create a user, right? So let's go ahead and let's try that out. So we'll go back to our crude, and we create a new function that gets a user, right? That gets a user by email, right? So I'll call this the function that gets user by email. And of course, as this function will always take session, right? Which we already know that every time we want to interact, of course, that we need to create a session for that interaction, and then we need to close the session. So you tend to see that all our CRUD function will likely carry session as one of the parameter, because we need it to for this interaction. We need it for the interaction. Okay, so for this particular function, right, we need the session and we need that email. We need the user email, right? We need the user email. And the next thing we could do again is to actually carry out the actual interaction, right? So once the session and the email has been provided, then we can do what we can interact, right? We can actually interact. So we could say user, but I want to actually assign this whole operation to to a variable called user, and then I would simply say session dot query. All right. So once we intend to actually fetch something from database, all right. Once you're not adding, once you are getting, you use query. You use what? You use query. Unlike when you're adding, you use what? You use the add method. So once you are getting something from a database, you use query. Now these functions are actually defined by SQL Alchemy. So that's why I said that in our spare time that we will look up that documentation. SQL Alchemy is an external library, right? It has no affiliation with Fast API. Okay, but what I want you guys to actually note, okay, is that whenever you want to actually acquire information from your database using SQL Alchemy, you make use of what? Of query method, right? Make use of query method. And then when you want to actually save information to your database with SQL Alchemy, you use what? You use the add method. So those are the two things that you should take note. Very important. Okay, they're very important. Okay, so now what you want to query now is the table you want to query. So what table are you querying? In this case, it's our user table. So I'll simply bring this man from here and just put it there, because that is our table that we intend to query, right? That is our table that we intend to query. So basically, this man here will just bring everything that is in that table, that is in our user table. So we can further filter out what we want and leave the rest, because this command here like this will simply what query everything, will simply fetch everything from where? From the user's table. So here we are basically saying here that after fetching all these things, I want to go ahead and still filter. So filter is also a method that SQL Alchemy has provided, and this filter takes in conditions, right? Takes in things that you intend to do what to filter out and to filter for, and then it will carry out that condition, and then if it checks a record and that condition matches, then it will filter out that particular record, and it will keep doing that till it gets to the till it fetches every record that matches that requirement, right? So in this case here, I basically want to check the user table. So I basically want to check the user table, and then inside this user table, I want to dive deep into the email column, right? And then check if there is a value in the email column that matches this email that we provided, the email that the user have used in signing up, right? If there is, then I basically want to filter it, right? And if there are more than one, then I want to get the first one, right? I want to get the first item. So all these methods that you're seeing here are basically method that SQL Alchemy has provided for us to do to use. So the filter here, this filter method will always return its value or always return its result in a list, right? It returns the result in a list. So you can either use list method to do what to actually fetch whatever information you need in that list, or you can use built-in method like this from SQL Alchemy to do what to get whatever results you need. Which in this case we want the first value in that list. So if it's just one, then just get just that single record, right? So this first method here will simply do what will simply pick that pick the first record and do what and we'll return that first record if available, right? If available, then at the end of it all, we simply want to return the user, right? The user with that particular email. Do you understand? Do you understand
Yes,
what just okay, that's perfect. That's perfect. All right, so right, so having that now in place, so we can simply use this function, right, to carry out the validation to make sure that a user with a specific email does not actually exist yet, right? So going back to our main.py, we can simply do that. We can simply do that. So we can call that function by saying user should be equals to CRUD dot get user by email, and I'll pass in our session, right? And then I'll pass in the user email, which in this case is user dot email, right? User dot email. Now I want to check if user, so means that this if user there simply means that if we carry out this query, right, and there is a user, then what we could simply do is to let the user know that that user already exists, right? That user already exists. So if user, then we can now come here and return appropriate error, right? Right. So if there is user, then we return the appropriate error. So in that case, this other part of the code wouldn't get to do what to execute. But if there is no user, right? So if this actually carry out this query and no user actually exists, right? Then the if condition here would not actually execute at all, right? Would not actually execute at all. Okay, so go ahead and let's begin our HTTP exceptions. Okay. It's already imported, so we will simply just do that. So coming back, we will return, we will raise rather, we will raise our HTTP exception here, right? So HTTP exception, and we will go ahead and we will provide our status code of let's bring in, if we use 409, okay, we use 409, and we will also provide a detail of this information saying user already exists. Okay, so that should do. This should be in a, this should be in quote, sorry. All right. So basically that is everything we would need. That's basically everything we would ever need. If user does not does not exist. If there is user, then this should drop. But if there is none, then that should go ahead and execute the rest of our code. Right? That should go ahead and execute the rest of our code. So let's go ahead and let's test this out and see that is working as expected. So bring up our postman. Let's see. All right. This was where we left off in our previous class. Okay, so right, so this, I believe this was the data we used in our previous class. So let's go ahead and let's just try to resubmit this data and see if appropriate error would do what would show as expected. If appropriate error would show as expected. Let's go ahead and let's run our code with UVCon, and colon dash reload. All right, so our server is up and running. Let's go ahead and let's make a post request again. So it said could not send, or couldn't send the request. So let's fight again. Right, so we see that we get what we get the appropriate error, right, saying that the user with this detail already exists. So by now you can already tell that that our database is working very well, right? So we do not need to bother of if we close the terminal, if the data that was saved previously is lost. No, it's not lost. The lead time that data that was saved will get lost is when we don't, which is when we actually deleted that file there, codecamp.db. So for now, we are using that file as database, and which we've already mentioned that SQLite is a file database. So that, there it is. So it's actually working. So let's try and create another user with a different credential, and I believe it should work as expected. So I'll just simply add one here. That should make that user a new user. So we go ahead and send another post request. It says internal error. It says non-type. Okay. It's why is showing right. Hold on. There's a bug now. Cool. It happens that we are having a bug somewhere. Any code that comes after our exception happens not to be executed, which shouldn't be so. Hold on a second, guys. That should work. So then come out 7. Okay. Hold on. Okay. Okay. So let's change this to the existing user. Sorry, please. I think we're having variable conflicts. So let's change the existing user. All right, so that should sort everything out. So sorry about that. That was variable conflicts at some point. So right, so let's go ahead and let's try that out, and this should work as expected. All right, so a new user has just been created, and then if we try to create that same user again, we should now have the appropriate message saying that that user already exists. That's a typical example of how your sign up page or how your sign up functionality should actually look like, right? How your sign up functionality should actually look like. All right, so before we actually pull that up, let's talk about one more thing. All right, let's talk about one more thing, and let's talk about relationship in SQL Alchemy. So I'm going to talk about briefly about it, right? So you have an idea of what it means. Okay, and like I always said, where you need to more of it, then reference the documentation, right? The documentation actually covers all the possible relationships, right? But what I'm gonna do now is to basically give you an idea of what that actually means, right? Of what that actually means. All right, so relationship is basically a process of mapping one class with another class, right? So it's more like it's more like of you defining how one class should relate with another class, right? How one class should relate with another class. So that's basically what relationship is, and there are different types of relationship, right? There are different types of relationship. right? We have the one-to-many relationship. A typical example of one-to-many relationship is the one that we are having now, right? So one-to-many. Okay, so basically, I'm the tutor and you're the student. So the relationship that I'm having now is I'm the only tutor, okay, referencing many students, okay, one-to-many. Okay, and then a typical example again could be a typical example of one-to-many again could be a user having multiple addresses, right? That's a typical example of one-to-many relationship or one-to-many relationship. Then we also have another one. We also have another one called many to one, right? So the opposite of that of one-to-many, right? Where many records in one table can reference a single record in another table, right? In another table. We also have one-to-one, right? One-to-one. A typical example of one-to-one is you and your profile, right? Your profile, your Facebook profile, your Instagram profile, and the rest of them. So you cannot actually have let's say you cannot have one email. You can't use one email, right, to have multiple Instagram profile. It's not possible, right? So one email to what to one profile. So that's a good example of one-to-many relationship, right? We also have many-to-many relationship. So a kind of relationship where records in two tables can be related to many records in each other, right? So um, one multiple record in a particular table can actually relate to multiple record in another table, right? So all the relationship actually boils down, okay, to what exactly I'm trying to do, what to implement, right? So if I'm trying to actually build a system where I will have a user and then user can also have their profile. In that case, one-to-one relationship is what is exactly what I need, all right? Is exactly what I need. Is exactly what I need. So and then but then if I want to build a system, okay, sorry, a system where I can have a table for author and also have a table for books, right? Then in that kind of system, I can make the users, right? Sorry, the author to have what a one-to-many relationship. And reason for that is that one author, right, can have many books, right? So one single author can actually write as many books as possible, right? So we can actually control that. So it all boils down to how you want to do what use it, how you intend to do what to use it. So let's put up a very simple one-to-many kind of relationship, right? One-to-many kind of relationship. So it's not actually compulsory, but believe me that most of your application that you'll be writing, there is likely going to be a relationship between tables, right? One table has to communicate with another table at some point. Okay, so the detail of every relationship, you can actually find them in SQL Alchemy documentation, right? Like if I want to cover that whole detail, we may likely not finish up. All right. But then I'll pick one or two of frequently used ones. Okay, frequently used relationship that you mostly use all the time. And then we'll talk about how we can implement that in SQL Alchemy. So let's look at one-to-many. Let's see one-to-many kind of relationship. Right? Let's see one-to-many kind of relationship, how it's actually being implemented in SQL Alchemy. So once again, let me remind you that is available, and Alchemy is independent library. It has no affiliation with fast API. So if you intend to know more of more methods that live within this library, then you can do well to visit their documentation. You can do well to visit their documentation. All right, so I'll go back to my models, and I will okay. We will work with this existing table. So I will simply just create a new table, right? I'll simply just create a new table here, and I'll call this table address. address. Address, okay. And then rather then address is supposed to be a collection of address for users, right? But then I also want these users to have a one-to-many relationship where a user can have as many address as possible, right? As many address as possible. So I will almost the same thing. Okay, I'll have my table name and my ID here as well. So my table name here. I'll have my table name here. I'll have my table name here. And for table name, I would simply call these addresses. Okay, addresses. And and then the address itself, the address itself. Okay, so one more thing here is I'll simply come here and put here address or residential address, rather residential address. And then and then after that, this would basically be a string, right? This would basically be a string. So we put that there, and uh, and then and then we will simply come back to our user table. Come back to our user table, and what I want to do now is to do what is to create the relationship between these two tables. And to create a relationship, we make use of a relationship class, right, that exists in SQL Alchemy. So which we can actually import it and use it in our code. So there's a class called relationship. So you simply import it from sql.orm, from SQL alchemy.orm. We need to bring in relationship. Relationship. So relationship is what we will use to create relationship between two tables, right? Two tables. So first of all, what you need to do is you need to provide a field in one table that you intend to do what to create a relationship with the other table. Okay. So I'll go back to my user table, and then I will create a field, all right, a new column, and I'll call this column address, right? And then this address here, I would simply assign it to a relationship class, a relationship class. And then this relationship class it takes in the the table that you want to do what establish the relationship with, the table that you intend to establish the relationship with. In this case, you put the table name in. The table name here is address, right? So this table name here, or the class name rather, so class name. So in this case, it is what address. So that way, it automatically creates room for you where a user can actually be associated with what with addresses, right? With addresses. Now, after that has been done, we can also create a bidirectional mapping by providing a second argument called backpopulate. And then you provide the field in the other table that you intend to reference the user table, which in this case, I'll just call this user, which we will create this field down here. So I'll copy that user there and come down here and provide that field here as well. So I'll provide a field here, and I'll also create a relationship here as well. And then this one around, we'll be creating a relationship with the user table. And we also do back populate to address as well. Same thing, right? Same thing here, same thing here, same thing. This time around, we'll be referencing the other field that holds the relationship. All right. Now, now let me re-explain that again, right? So in order to establish a relationship between two tables, right? So we make use of what of the relationship class. Now this class takes in the table that we intend to do what to create the relationship with. Okay. So for the address class, right? Where's my cursor? For the address class, right, we intend to create the relationship with what with the user table. So we basically repeat the same thing for the user table as well to also establish the relationship between the user table and what and the address table. Okay. So now having that, you can now do what? Do this and also do this as well. Now, I also said that we can also specify a second parameter for the relationship for back populate. So back populate is more like creating a two-directional mapping where I can actually get get a specific user, and from a specific user I can dive deep to the addresses that user actually have. And same thing happens where I can actually do what? Get a specific address, and I can do what? Simply get the user that does what? That owns that particular address. That owns that particular address. The same thing happens here as well. Same thing happened there. So one more field that I want to actually add here is the user ID, the owner of this particular address. The user ID, the owner of this particular address. So it will be this address, this will also be a column. Okay, this now note that this particular one here is not actually a relationship, right? I'm adding additional column, right? Now this column here is basically going to be holding the ID of the user that owns that particular address, right? These fields here are basically the relationship that I intend to create between these two tables. Okay, so this one here is going to be an integer column, right? An integer column. But then I can't just randomly put in any integer there. But then what I could do, I could make use of what we call foreign key with mapping. So where once an address is being specified and then an ID is being specified, then automatically we can map that ID to a user that owns that particular ID. That's what foreign key does, right? So it associates that user with that particular address. So to make use of foreign key, we simply import it as well. Same thing, similar to how we imported the column, the string, and the integer. We can as well bring in the foreign key. Foreign key. We bring this man in here. We put it there. And this foreign key will basically be holding the users dot id users dot id values. Do you understand what is going on there?
That is for medium.
Okay. Give me a second. Give me a second there. my mouse. All right, so let's go about the entire process one more time. All right, let's go about the entire process one more time. Let me just stream this thing. Let me stream this thing. All right. So far, what we've done here is we've basically created two tables, right? We've created the user table. We've also created we've also created the address table. Then for the user table, we've added some columns, all right? Such as the ID, first name, last name, and email, right? And we've also established a many to one relationship with the address table, right? With this, so what the last field that we are seeing here is basically us doing what, establishing a one to many relationship with the address table. So now what that place there is, what is telling SQL Alchemy is that one user can have multiple addresses, right? One user can have multiple addresses. That's basically what it means. So and then we did the same thing. We did the same thing with the address table. So we also established a relationship that we also established a relationship that connects each address, right, back to the user table, right, back to the user table. But then where it gets tricky is why do we basically need to put these things in two of them on both table? Probably that could be what is confusing us. Why do we need to put similar relationship on both table? Right now, this is how SQL Alchemy actually recommends that we do. Right? So establish your relationship with table you interact with, and not the table name. When I mean table name, this is what I mean by table name, and when I mean class name, this is what I mean by class name. So this relationship, they basically take in what the class's name, which in this case is the address with capital A, the address here, and this other one here is the user with capital U. So when we do that, then it gives us the ability to do what, to carry out that relationship where one user can have multiple addresses, where one user can actually have multiple addresses. Are we making sure? Is that okay? The lady that asked the question.
So please, I have a question.
Now, what's the question?
Okay, so if you want to relate three tables, you see the same process.
If you want to do what?
If you want to relate three tables, you see the same process.
To relate with three, yes, it's actually the same process. Now, see, the thing is that the way SQL Alchemy works is that unlike Django ORM that actually handles bi-directional mapping automatically, SQL Alchemy does not. We actually you cannot not happen, right? You can actually take that off and nothing will do what will happen. It will still work as it should work, okay? But then the problem is this. Right? They they only be able to table from the user table, but you'll not be able to access this user table from the address table. So what do I mean? Had it been let's assume that I get a user, right? Let's assume that I intend to fetch a user somewhere. So I'll put a comment somewhere here. I'll put a comment somewhere here. Now let's assume that I intend to I want to query a user with a specific ID. Let's say I go ahead and say session, right? Dot query, right? Session dot query, and basically what am I querying? The user table, right? I query the user table, and I and then at the end of it all, I want to get a user with a specific ID, right? I want to get a user with a specific ID. So now what I would simply now do is just filter out. So I'll come here and then I say dot filter, right? Dot filter, and then I want to filter user dot ID that is equals to what 1, and then get the first user, right? Now this will give me what a specific user with a specific user with that particular ID. But now that I have this user, I can actually move from that user without necessarily leaving the entire query to go and start querying the address separately. I can still link this query from this user down to the address by simply just saying, okay, I want to get the user that owns this address, because now this address here is what is this field here. Now, once I reference that field, it simply means that I now have full access to what to the address table. Yes, I have it. Right. Are we there? Okay, so now with this relationship now, right? So it simply means that that I can do what that I can simply do what I can simply now move from user down to the address. And then I can then further go ahead and say, well, okay, now get me a user with the address, okay? And then with the address, it's let's say give me a second here. You just say address, then I could go ahead and carry out probably another filter here. because this address now will basically just get every record that we have in the address table. So we could now go ahead and then we could just filter and then provide whatever parameters that we intend to do to filter. So that's the whole purpose of relationship, means that I can migrate from user down to address. And same thing happens when I also provide the same relationship here. It simply means that I can do what, that I can still make some query to this address and then eventually move from address to where, to the user, right, depending on what I actually intend to do, what to get. Probably I want to, let's say I want to actually filter a specific address, then I want to go ahead and dive into who owns that particular address. That way I don't necessarily need to let's say get the address and probably get the user ID and then now carry this user ID and now explicitly now move to go and do what, to query the user table. But then with relationship, I can simply do what, move from where I am directly to where, to the user table. That's the whole purpose of relationship, the ability to move between tables, right? The ability to move between tables. And then depending on the relationship, then it will also define the structure of how data is being saved in the database. So it all depends, right? It all depends. Does that making sense?
Yes, sir.
Right. But then don't worry. Let's see. Okay, this what we will do, right? To help us make a lot of sense with this. Okay, so because already we are close to project phase, and I intend for us to have 1 full week, or where we don't tutor again. 1 full week where we build projects. This is what we will do. Think, when is the project phase starting it exactly? Does anyone have an idea when project phase is starting exactly? Anyone have an idea when project phase is starting exactly? Anyone? Anyone?
No, sir.
Okay,
No, sir,
so
but I think it will be after when all the tracks are done with their final tasks.
right. So let's assume that we have like 2 weeks more. So that by next week we should be done tutoring by next week. Right. So now what we're gonna do by next week is that next week we should wrap up everything tutoring next week. So we could build a mini project in preparation for project phase. Right. The intermediate, we're almost done with that. So just us, the beginner, that is thing with the one behind though. So but there's no problem. So what we will do is this. Okay. Over the weekend, there is tax, no doubt, but over the weekend, please take your visit SQL alchemy documentation. Right. During the phase where we are actually gonna build projects, we are basically going to open up almost every documentation that we need. All right. So what do I mean? Because once we move into building of projects, we're making use of render for deployment. So render is also is a third-party platform, right? So I won't just come here and then start typing out this code like this, because it seems like when I come and sit down and start typing code like this, it makes it looks as if I'm the author and finisher of this code. No, no, this is someone's documentation, right? This documentation is there, and the guide is there on how to use this third-party application, right? So we also be using Cloudinary for file storage, which I said that we are going to do in this class, but we're already running out of time. So Cloudinary is another platform where we'll be using for file storage. So please, it's two different things. File storage and database is two different things. Are we aware of that? File storage and database are two different things. Are we aware of that? Are we aware of that? File storage.
No,
Yes, sir.
no,
No, sir. No, sir.
All right. So the person that said that she's aware, can you help us? Can you help those that say that they are aware? Explain to them different between a file storage and a database. Different between file storage and a database. Different
So
between,
in my own understanding,
okay,
database is where organized records of
okay,
what you want to store.
okay,
Is then file storage are like documentations you keep.
okay.
Yes, sir. That's my understanding.
Right. So and well, is perfect, right? Almost perfect though. Almost perfect though. Okay. So I think the main thing there is organization, right? How those files are being organized. So for a database, especially for the ones we'll be using for a relational database, things are being stored in rows and columns, right? Things are being stored in rows and columns. Then basically what a file storage is more like your drive. Things are being stored based on path. So if I need a specific file, I simply need to navigate to where that file is, to that file path, and then do what, I'll get that file. So that's basically what the major difference between a database and a file storage, and also and also the way of retrieving these files, right? Now I can actually, for a database, I can retrieve a record probably by ID, or let's say by any primary key. But for a file storage, right? For a file storage, I basically need to to locate that particular file by the file path, by the path of that file, right? So and also we wouldn't also, now the reason why we wouldn't actually want to save our files to database is that at times, if you are building an application where you need to actually get things like profile pictures. Now we'll be using a free database from Render. It's a very small size, and it wouldn't be nice that you now pack people's pictures and then can put there. Before you know it, the small size that they gave you for free will then get filled up. So that's where Clarinary comes in, where we use Clarinary to do what, to save our file, and then we simply save the file path of that file to our database. I don't know if you are getting the whole concept. We put the file in Clarinary, and then we save the path of that file to database. Does that make sense? So during deployment, we are going to see how you create an account and purchase a Postgres, not purchase though, and get a free Postgres database. And then we also get a free Plenary account. So everything we'll be doing is going to be free. On that same day, we're going to look at Git. And because in order for us to actually deploy, we need to understand fundamentals of Git. And ability on, and then we now look at documentation. Documentation is quite straightforward and easy. It won't even take us to 5 minutes. And because the truth is that everything that we've been doing so far is automatically being documented. Okay, now we not just see it, but it's there, right? And I'll show us where it is. It's just there. So basically, what we do is probably just add some few things to the documentation, and then that is all for documentation. And then we start preparing ourselves for the project itself. All right. So out of time, we can actually proceed again, but time is no longer on our side. Okay, but then what I want us to do is, please, first of all, do your task. It's very important. This second to the last task. After this task, you have just one more task left, and that one more task is going to be all right. I believe that that the admin already made that extremely clear that that the last task will carry more priority, like more priority compared to other tasks you've been doing. So it it now it would be nice that you've done 7 tasks and then the 8th task probably you submitted late and then because you submitted the 8 tasks late you cannot do for the first. It's not really nice, right? It's not really nice. It's not really nice. The last class video, it should be, if it's not there, then it's just give it a couple of days. It should come up on YouTube, please. If not there, give it a couple of days. It should come up on YouTube. All right, give it a couple of days. It should come up. All right, so but in the so basically that's where we'll leave it there. At some point, my network kicks me out. All right, so and please, in the absence of anything, let's leave it there and I'll see you guys on Monday. And as like I said, for those of us that are still not in the current stage, I don't know how we do it, but I wish you guys can actually help you guys out, help yourselves out, and see how you can bring everyone on board. Do the people that are currently on stage I think stage 6, you guys are much, but then there are some people that are far behind, and for some reasons I don't know why, but they are far behind, right? But you guys are already much, and but I'm not saying that 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 we should leave the other ones behind, since you guys are much, right? So please try and reach out to your team member and help them out in whatever way you can, right? So please, you have a wonderful good night rest, and see you guys on Monday. See you guys on Monday, 7 p.m. West African time. Please do your taps and submit on time, please. All right, bye for now.